Hello everyone, I'm Yukang Cao. I'm going to present our paper JIFF jointly aligned implicit phase function for high-quality single-view closed human reconstruction. This is a joint work with Guanyin Chen, Kai Han, Wenqi Yang, and Kenneth Wang. First, let me walk you through the single-view 3D human digitization. Given an input image, there are mainly two types of methods, model-based method and model-free method. Although model-based method is robust and computationally efficient, it could produce round poles, has minimal closed details, and exists discrepancy for large poles. Meanwhile, model-free method has better pose estimation, more closed details, and a better aligned pose. The most pioneering work of model-free method is PyFu pixel-aligned implicit function. They employ one single MLP to predict occupancy value and vertex color by inputting the 2D pixel-aligned feature and normalize the depth value. The main idea for PyFu is the implicit function. The implicit function takes the location and feature information as input and outputs the occupancy value. Moving from PyFu, there are several methods trying to improve either its details or robustness. Model-free method, for example, PyFHD, only include 2D image and often suffer from step ambiguity problem. In the meantime, model-based methods such as ARC, GeoPyFu, etc. are proposed to utilize parametric model but often produce shapes that lack of geometry details, for example, face. As mentioned in the previous slide, although this method achieves impressive human reconstruction, it still lacks face geometry and texture. Therefore, in this paper, we propose a new framework called JIFF to reconstruct, first, better face geometry, and second, better face texture, by integrating 3D parametric-based model into the learning pipeline. We employ a 3D morphable model. It models a face as a linear combination of the PCA basis vectors. Most importantly, it's robust in both shape and texture aspects. In our network, we follow SOTA methods to implement ResNet to predict 3D-MM. In principle, any other efficient face or head models can be employed to our JIFF framework. However, you may wonder, what if we directly combine PyFu reconstruction with 3D-MM? Unfortunately, it is non-trivial to stitch them together due to their specific geometry. Therefore, we propose a novel JIFF network to jointly utilize 3D face file from 3D-MM. Given the input image, we first use stack hourglass encoder to extract the 2D image feature. Then by using bilinear interpolation, we get the 2D pixel line feature. As for the 3D face file, we first crop out the face image, followed by using ResNet to estimate 3D-MM mesh. We then use PointNet and 3D-UNet to extract logo and global features. Similarly, we use trilinear interpolation to get 3D space aligned feature. We propose to jointly train the MLP to learn the occupancy value. A close-to-fine network is proposed to train the texture pipeline. Similarly, we use texture 3D-MM mesh to provide both texture and shape information. The close part is based on low-resolution data and geometry feature. We then upsample the data to high resolution to get better texture. In the fine pipeline, we treat 2D image feature, the output of the intermediate layer from closed MLP, and the 3D face feature as input. By jointly training the MLPs, we will get high-resolution texture. And overall, we get 3D human reconstruction with better face details. Let's enjoy some animated experimental results. Through this animation, our method JIFF achieves better face details, which is best aligned with the ground truth model. Our method is the only method successfully reconstructing the ears. By using the texture information from 3D-MM, our method improves the face texture to a higher level. We quantitatively compare our method with existing SOTA method on face region. Our method is the best among the compared SOTA methods. Here are the animation of the full body reconstruction. We did quantitative comparison on the full body region and achieved the best result. We also evaluate on the body-only region. Thanks to the better learned representation, our method achieves better performance over PyFu. Thank you very much for your time and welcome to our poster 70B and our website.